Welcome back to another day of hacking on this LED marquee sign. Well, few quick changes. Recording in a slightly lower resolution because I found out after the fact last night that part of the last video got chopped off because my memory card filled up. Also, I'm having problems editing the files just because they're so big. So, switching from a 720p down to like 600-ish, I think is what the next resolution down was that my camera can record in. And also, I switched lenses to a wider angle lens to hopefully finally eliminate the problem of me talking about this chip here when it's, off the edge of the screen. The one downside to that, as you can see, is it's a very fisheye type lens, so the stuff out here is sort of curved and distorted. But if you want, leave me some feedback. Tell me if you prefer the more flat but smaller view where occasionally I'm talking about stuff that's off the display, or if you'd rather have the wider viewed but distorted due to the fisheye lens. So that's it for the little intro here today. And back to this. One thing that dawned on me when I was watching and editing the first video is what this connector was for. If you remember, this was a little dip socket with nothing in it, and not really set up for any sort of IC, and I was speculated that it was for a cable that went off to some other device. This LED was for the tape transport. So I'm willing to bet that this here was the interface cable to the tape transport device. So, don't have one, never will, so it's no use to me, but that sort of explains why this had data outputs, data inputs, and some control lines to it. It was such that the processor here could feed data out to some sort of tape device to store it for later retrieval. Another off video update. I did some searching on microcontrollers, and for $2.50, $3, I can get a micro with 4K of RAM in it, and it runs at 64 megahertz. I'm not going to keep any of this RAM. For that price, I'll just buy the $3 micro with the built-in RAM and then not have to manage this external stuff. So I think my next step's going to be I'm going to remove all the SRAMs, the two EEPROMs and their sockets, and the microcontroller and its socket. Once that's cleared out of here, it'll open this space up so I can easily trace where these buses go and sort of plan my next stage of attack of what's going to be removed. Eventually, I want to get this down to just the data and address buses that control the LED 273 latches and any associated pull-up, pull-downs needed for that. My hope is once I get this all cleared up, is I might be able to slice this card, sort of right along this row of chips all the way across, just to sort of shrink the outline of this card to make it easier to mount inside the wall. Now, with the size it is now, it's not too bad, but to get two of these displays hooked together, I'm planning on slicing off this end, which just these traces here just route it down to these LEDs, so it's no big deal that they get lost. This power trace here, again, just powered these LEDs, no big deal. This trace right here, I need to do some checking on yet. Goes to right there. I'm thinking that one can disappear as well. Yeah, that goes to the reset chip. So, basically all the traces on this edge of the card, with the exception of probably this one right here, which, worst case, I can reroute it if needed, can go away. And then I can do the same on the other display and flip it 180 degrees and then line it up right on this line so the two cards are planar and the spacing between this row of LEDs and the first row of LEDs and the next sign is this exact same gap. But if I do that without cutting this bottom off, this one's going to stick down yay far on this side and yay far on this side, and you'll have this sort of Z-shaped long assembly, which will take up quite a bit more room on top of the wall. So if I can shrink it down so I have about that much space on both sides, so it's more centered around the LEDs, which I should be able to do, and that puts the cut line right about here, then it'll just make this whole packaging that much cleaner to put into the wall. While I'm talking about packaging, this thing is really floppy. So the other thing I need to address when I get to that point is how to stiffen this up. Now I have 2 rows of mounting holes. Unfortunately, none of them are really directly in line with each other, but they're pretty close. So I got 1 row through here with that hole, these 2, that one, and this one. So I'll make some sort of aluminum bar and standoffs that goes through there, and a second one that goes right along where these 2 are. Now I only got 2 holes, which leaves these 2 ends kind of floating free. There's plenty of space right here to drill a hole and put a mounting hole. And then this end, when I cut this, there's not going to be a lot of space. So I may have to either put just sort of a rubber bumper there just to keep it from shorting out on the aluminum backer, or maybe I'll put a hole up in this corner of a smaller diameter and tie that back in. But nothing I need to address right now. I'm sort of short on time today. I got some other things that need to get done. One of which was mowing my yard, but that's totally not happening due to the non-stop rain we've had for the last 3 days. So we'll just get straight into this and start popping chips out. At some point here, I need to find a better way to store ICs in my vast collection of random stuff. It'd be ideal if I had little cubbies where I could put every single TTL whatever in its own little box and file it away, but I don't. The vast majority of my parts get sort of sorted by category into little folders and then sorted into boxes for storage. So then I can look up in a spreadsheet, okay, I need part X. It's located in box 3, folder 16. Now, when you have hundreds of thousands of random ICs, I don't have hundreds of thousands, but I definitely have hundreds of random ICs, and sometimes I only got 1 or 2 of any given one, it doesn't make sense to put each one in its own folder. So I need to come up with a filing system where I can have sort of a folder with a carrier tray that I can stick the ICs into, sort of like big sheets of conductive foam would be awesome. I'm kind of cheap, so I probably won't go with conductive foam, but I may go with pink styrofoam coated in aluminum foil. It gives you the same ESD resistance because the tin foil will conduct any charge that gets on it equally to all the legs of the parts. The downside to doing that is it's a perfect conductor. So the ESD foam, the black stuff that ICs normally come in, has some resistance. So over time, as the charge spreads, it will bleed off. But topic for another time. So I popped out all the ICs that I'm going to make disappear. I think I'm also going to get rid of this cap since he's just in the way. And I also will probably start pulling these little decoupling caps for the parts that are missing. Again, I think I'm going to cut this down and sort of shrink everything to a, to a board that is the same width above and below these LEDs. So when I start flipping these around to make the bigger display, it all maps out correctly. Let's start up in this corner. And is it hot? Unfortunately, these big caps have a lot of metal in them, so they tend to quickly dissipate whatever heat I can put into them to desolder them, so they're kind of a pain in the butt. And once again, didn't quite get them fully clean, so these little piles of solder underneath the pins is a good indication that this card was wave soldered, which in the 80s was a pretty typical method of assembling cards like this. So what they do is they'd run this card through a wave of molten solder. So they'd have a big vat of solder, hot melted solder with a little pump that'd make a little ripple on it, and they just run this through the top of the ripple, which would solder all the pins on the backside of the card. But if you had a small pin in an oversized hole, or any pin in any hole for that matter, caterpillar action would suck the solder up through the barrel around the pin, and sometimes it would pull on the top side of the card, which can cause shorts in some cases. So it's kind of a pain in the butt if you get things out of whack and get too much solder deposited by your wave solder equipment. Today's modern electronics, which are mostly SMT, they go to an IR reflow type process where they put a solder paste down, which is little teeny weeny balls of solder suspended in a sort of waxy flux, and then they'll have a mask, and they'll just sort of almost silk screen the paste onto where they want the parts to be, put the parts in the paste, and then run the whole card through an IR oven, which is sort of, ginormous toaster oven that heats the entire assembly up to the melting point of the solder, and then lets that reflow before going through and cooling off.